All right, in this lesson, we're going to take a look at the concept of solutions and what dissolves, and also what forms precipitates. So what do I mean by what dissolves? Dissolution is the noun. It means you take an ionic compound and you break it apart. So I'm going to give this a more generic definition. Dissolution is really just when anything dissolves. Ionic compounds, when they dissolve, will break apart into individual ions. Covalent compounds, of course, when they dissolve, they don't actually break down. They stay together as an individual molecule. But ionic compounds, when they dissolve, break into individual ions. We'll look at that in just a minute, what that looks like. What forms precipitate? So the idea of precipitation is the opposite of what happens when you dissolve something. So precipitation means that you form a solid from the dissolved ions. We'll write equations for both, and you'll see that they're just exact opposites of each other. How do we know if something will dissolve or if it will form a precipitate? There's a list of solubility rules. This is found on the back of my periodic table, and there are other lists out there that will make it easier to tell if something dissolves. There are literally hundreds of ionic compounds out there. How do we know for all of them, well, will this dissolve or will it not? There's no way you want to memorize all the different possible compounds. Well, there's sodium phosphate, and there's sodium sulfate, and there's sodium carbonate, and sodium hydroxide. Rather than memorizing each compound and whether it dissolves or not, chemists came up with this list of rules that works almost all the time, makes it really easy to remember what dissolves and what doesn't. And one of the rules tells me if there is sodium in it, it dissolves. Always. So sodium carbonate and phosphate and sulfate and hydroxide, those all dissolve. And I know that because there's one rule that applies to all salts containing sodium or potassium or whatever. So notice that there are rules based on categories of chemicals. The first rule applies to anything that has nitrate or acetate in it, and the two formulas are given there. The second rule applies to any alkali metal like lithium and sodium and potassium. And then it also applies to the ammonium ion, which is NH4. If it's got that in it, we can apply rule 2, and on we go. Sometimes two rules apply. Note that at the beginning it says rule 1 is more important than rule 2. We follow that rule first. So if you find a compound and there's two different rules that apply, go with the first rule to decide what dissolves and what doesn't. Also notice there's a little description down when you get to rule 5 that says slightly soluble, and then in parentheses that says just count this as insoluble. There are degrees of solubility. It's not all or nothing. Some things dissolve a tiny bit, but when they say slightly soluble, that means like sometimes very slight, like maybe one particle out of a million dissolve. So for all intents and purposes, we say that thing will be insoluble then if only 1 out of a million of the particles breaks down. Let's apply the rules to some different compounds and see how this works. Does it dissolve? Does sodium chloride dissolve? Let's see. Sodium chloride has the formula NaCl. So we go over to our solubility rules. We look at a rule that would apply to sodium chloride. And you can take your pick on this one because there's a rule for things that have sodium, and there's another rule that has things that contain chloride. So we could apply both of these rules, but remember the instructions said go with the first rule that you come to. So rule number 2 says if it's got sodium in it, then it is soluble. Sodium chloride would dissolve. When you represent an ionic compound dissolving, what you do is you show it starting as a solid compound and starting as combined ions. And then you break that into its individual ion pieces. So this would break up into sodium ions and chloride ions. If you don't know the charge of ions, you can find them on a periodic table. If you have customized your periodic table, you may have written above the first group that these all make 1+ ions. All of the alkali metals and hydrogen, they tend to form 1+ ions. So these are the alkali metals, which we just read in one of those rules. If it's got an alkali metal, it's going to dissolve. If you got a compound that has chlorine in it, when chlorine is an ion, it's over in this group that we call halogens. And you may have customized this group and said, these things all form 1- ions, the whole group. So fluorine, chlorine, bromine, iodine. Those ion charges are always -1. You also can look on the back of your table. There's a list of some common monatomic cations in this little orange section, so you could find sodium there. Oh, yep, sodium, it's a plus ion. And then chlorine, I see it right there. Chlorine is a minus ion. All right, so these things are now individual ions. They started together and kind of neutralized the charge, but now they're individual pieces. They started as a solid, and now they are dissolved in water. So the physical state is called aqueous. We write an AQ next to those. What about potassium nitrate? Potassium nitrate, KNO3. Let's see if there's a rule for this. We'll find out if that dissolves when placed in water. So for potassium nitrate, I can use one of the same rules because potassium is an alkali metal. I see it right here. But as it turns out, we would apply rule 1 here because it's also got nitrate in it, nitrate, NO3. It doesn't matter because both of these rules say these things are always soluble. So potassium nitrate dissolves as well. Writing this thing as it dissolves is a little more complicated. You may be tempted to write separate elements for each, but we don't do that in this case. This is made of a polyatomic ion. So the second half of this, the NO3, is called a polyatomic ion. We hope to be able to recognize some of these. Last semester, you may have learned about some of these when you were studying ions, and it's a good idea to know these. That way you'll recognize, oh, that NO3 thing, that stays together. That's a polyatomic ion. SO4, CO3, these are all called polyatomic ions. When something that has a polyatomic ion dissolves, water can pull apart the ions, can break the ionic bond, but this nitrate, NO3, is held together with covalent bonds, right? It's got nitrogen and oxygen. That means those nonmetals covalently bond. So this part of the molecule stays together. Water can't break the N apart from the O's. Instead, it just separates the two ions. So we're left with potassium and nitrate. Again, you can find the charge of potassium on the periodic table. On the front of it, you see it over in group 1. You know it's a +1, or you can find it on the back of your table. And then nitrate, also on the back of your table, we highlighted that already, is a polyatomic ion with a charge of minus. Potassium was a charge of plus. Don't forget that these form aqueous ions, so we write AQ. All right, let's look at another one, silver sulfate. So if we wanted to know if silver sulfate would dissolve, we're going to look in our chart, our solubility rules, and see if we put that in water, does it stay together or does it separate? If it's soluble, we're going to separate it. If it says it's not soluble, we'll leave it together. So now we're looking for silver nitrate, silver sulfate. Okay, so you're going down looking for rules. Sometimes students get a little misled by that. They see silver and go, oh, I see a rule for silver. Silver is always soluble or something. This silver, that's not a rule for silver. That's actually a rule for things that have chloride, bromide, or iodide, and then some of the exceptions. So That's not a silver rule. That's a chloride, bromide, iodide rule. That does not apply here, but there is a rule here. Rule 4 is for sulfates, and it says sulfates are, most of them are soluble. There are some exceptions, but silver is not one of them. So let's show this dissolving. And we do that again by breaking it up into ions. This again contains a grouping that we call a polyatomic ion. We're going to leave that whole chunk together as a single thing. And that means we've got some silver and some SO4 sulfate. All right, the charge of sulfate, if you don't know the charge of sulfate, you can look it up. Sulfate right here is SO4 2-. The charge of silver we can also look up. So before we do that, let me show you one of the things that students sometimes mess up. Sometimes because there was a 2 in the formula, students think, oh, I should still have a 2 next to my silver. Don't do that. That's not how silver ions behave. They don't come in groups of 2. There are some elements that do. We call those diatomic, but almost every single ion breaks into individual pieces, an individual ion, not a group of 2 of them stuck together. So what do we do about the 2 then? In order to balance the equation, we could put a 2 in front of it as a coefficient. We just don't want to write that as a subscript. And then also note that there's a charge on silver. You can figure out the charge of silver just by knowing that 2 silvers goes with a sulfate. So remember, the charges have to be neutral. So if the sulfate is 2- charge and there are 2 silvers, each silver must be a 1+. Together, those 2+ ions would balance out the 2- charge. Or you can also look that up. Again, a lot of these are on your periodic table. That monatomic ion is written Ag+. All right, and again, it dissolves into aqueous ions. All right, one more. What about barium sulfate? It's a barium sulfate. Okay, there was a rule for compounds that have sulfate. Let's see if we can apply that rule here. So sulfate compounds, sulfate, that was rule 4, are soluble except for barium sulfate. So barium sulfate is not soluble. That means we won't break that into ions. If it started as a solid, it's going to stay together as a solid. We could say no reaction or just leave it the same. That is true for any compound that is insoluble. What this means is if we somehow had some barium ions and some sulfate ions, maybe we got some barium out of some barium nitrate that dissolved and some sulfate that came from, I don't know, sodium sulfate or something that dissolved, and we mix all that together, these 2 things will not stay dissolved anymore. Those 2 things will grab each other, form a compound. It's insoluble, so they'll turn into a solid. This reaction is an example of precipitation. Notice it looks a lot like dissolving, but it's written backward. Instead of starting with a solid and breaking it apart, you start with these separate ions that stick together. That's precipitation. All right, I hope this helps you as you're trying to figure out how solubilities work and what precipitation and dissolution are.